Hello everyone, this is Mike and Zoe's here. Say hi.
Hello.
Hello. And we are ready to continue from where we left off. So let's hit play real quick to see where we were, right?
Hello.
Hello.
There we go.
Okay. There
Here
we go.
we are where the car moves.
The car
but
moves.
It doesn't move very well.
Doesn't move very well, doesn't rotate. So the movement is fully linear. And we can reset the movement because we can reset the coroutine, but that's a worry for another time. All right, so let's stop the code now. Right, yeah, one more thing we should have mentioned. We actually fixed the track, as you can see. So all we've done is we've put the models back to the center of where the actual object is for each of the tiles. This is a problem that we had in the last episode. And now it's all fixed and everything works with exactly the same code as last time. All right, so what I say we do, my darling, is that we start working on having our car actually stare at something. I think we can start with that.
Okay.
Okay? So then we're going to move that something at another point. So let's go ahead and open the code. So double click Game Manager or whatever. And there comes our Visual Studio.
Yeah.
Right, okay. Click anywhere and hit Control MO. I can't stand all of this mess. Much nicer. Give it a save. Not that it makes a change, but... Okay, so if we need to stare at something, right, what we are going to do is we are going to use an inbuilt function inside Unity that I think applies to the transform class, which is called lookAt. Okay? And it requires another transform.
Okay.
So that's fairly easy. So let's go after your last variable, car move speed, click there. Yeah.
Ah.
Click there, hit enter once, and make a serialized field. Oh wait, do we need to make it public? Let me think. No, make it public. My bad. Make it public. Transform. Track references. You're close. Transform. Transform. Come on, Zoe. Let's get hopping. All right, transform.
Sorry.
That's all right, no problem. And we are gonna call this one look target. Okay, so before we do anything, let's go back to Unity. Let's go to our game manager. Oh, we've already created it last time, I guess. Expand game manager. There it is. Oops.
Whoopsie daisies.
Whoopsie daisy. Okay, click on the game manager now and assign it since we're here, right? Might as well do it. So drag look target into the look target thingy. No, you're already there. What are you doing?
Wait,
Just drag it there. There we go. Done. Winning. Back to code. Okay. Now this is fairly simple. All we're gonna do is we're gonna go to our player motor. Hit Control MO just as you did in that. Now, right at the bottom, create a new update function. So, enter, void update.
Forgot a very important part.
Yeah.
But wait.
Oh, you put too many. No, because it automatically adds them. So,
Yeah.
just remove that. Remove the two squiggles that you made. All right, we're good.
In the private.
Sure, you can remove that. I mean, it's unnecessary. One more, dude. There we go. Okay, so let's start writing stuff inside update. What we're gonna write is just one line of code for now. We're gonna change it later. Don't worry, just start typing. It'll fix itself. Fix itself. So type the following: transform with a lowercase t. Right. So that's our car. Transform. It's there. Dot lookAt, that's what I was telling you about before. Open a round bracket. Game manager dot script, right? Because we're going to our singleton.
Yep.
Dot look target. That's why we made it public. There it is. Close the bracket, semicolon. All right, so what does this mean? That every frame your car is going to be turning towards the the look target object. Okay, so let's go to Unity.
Okay, Unity.
Yeah, and what you want to do now is hit play just to test, and then actually remove maximize on play.
Maximize. Okay.
Maximize, and dock the game view to the right. So drag the game tab. Yeah, now there to the, not too far. There. Oh, to the right, to the right, to the right. There. Okay. Now drag that a little bit to the left. There. So we have a bit of room. Now hit play. Now you'll see everything should behave normally. Now click on the look target and move it around using that square, that green square in the middle of the scene view. Now look at what happens. No, the square, not up and down. But your car is now staring up and down.
Oh.
So just the square. Grab the square. There. And move it about. Look at your car. See? It's now staring at this transform all the time.
It's supposed to go wee.
Well, we'll do that later. Okay. Now click anywhere, release it, and hit stop. Stop the code. So that's the first step for now. Okay, now what we are going to do is we are going to make the car move following the track, okay? But instead of it moving linearly from tile to tile, we're actually going to create quadratic Bezier curves. Ooh, that's a complicated word. Quadratic Bezier curves that go between the tiles, and we need to create a control point. Yes. Now, we've talked about this with you before last time, after we got off the mic, but let's explain it to a crowd. So here's how we're gonna deal with this. Now you guys hopefully know what a lerp is, or a linear interpolation. If you don't know, it's, let's assume we take 2 points, okay, in space, and one is the starting point, one is the ending point. And then linear interpolation allows us, just a moment. Linear interpolation allows us to go from point A to point B in a straight fashion using a certain variable, a float, that goes between 0 and 1 to get from the start point to the end point. In other words, if I'm at 0, I'm going to be at the start point. If I'm at 1, I'm going to be at the end point. And if I'm at, say, 0.5, I'm going to be exactly in the middle between the two. Right? So the way a quadratic Bezier curve works is it needs 3 points. Right? So you do a lerp between point A and point B, where B is the control point, it's called. Yes. Then you do another lerp between the point B and point C, so you get 2 lerps that work simultaneously. And then you lerp between the result of these 2 lerps, right? And that's how you get a curve.
3 lerps.
That's right. Okay, so obviously we should probably show some diagrams with this, but hopefully it'll become clear as we work through our problem here, right? So let's get started. Let's get cracking. All right, so go back to your code. This is going to be quite a lot of code that we're going to be writing. And let's go to Game Manager. So the first thing we're going to create is an array of control points under the tiles. No, undo this. Yeah. And go under the tiles there and do another hide in inspector. Make it public. And what you want is you want to make a vector 3 array. And let's call this one control points.
Last time we made it a list.
That's right. Just so you know, audience, we tried this before without you, just to make sure that we knew how to do it okay while we were recording, because we don't want to be fumbling too much. Nobody wants to watch that, right? Okay, so we've got the control points array. Now what we need to do is we need to initialize that array, right? So let's go to start. I think it's probably where we're doing this. Let's go take a look in the start function.
Oh, start.
Yeah. So where you initialize the tiles, what you want to do is you want to initialize the control points too. So right under the tiles, there, hit enter, and go control points. How many do we need?
Well, we need one for every tile.
That's
so
right,
we
just
need
as many as the tiles.
61.
Sure. So equals new. So it's a vector 3. So hit tab right away. Open a square bracket. Now we need to tell it how many. Do we know how many tiles we have by this point?
Well,
Look at the code.
we got tiles.length.
That's right. Tiles.length. So you can feed it exactly the same information without having to recalculate it because you already have it. How nice. Now close the square bracket and semicolon. We'll populate it in a moment. Now we cannot populate it right away because we need several calculations before we can decide where to put these points, right? Mm-hmm. So we're not going to do it right away. We're going to do it in another loop that's essentially identical to the previous one, but later. Okay? So let's begin by doing that. We're also going to need to create a few variables on the fly, right? Mm-hmm. So, well, actually, I think we should explain how we're going to do this to people. So let me quickly grab GIMP and doodle around a little bit. So I'm going to take this point where the car is, more or less. Let's see if I can put it vertical. Oh, there we go. Okay, and let's hit hold the
Control?
No.
Shift.
Is it control? I can't remember. I can't remember now. I think it's alt. Hold alt and hit the print screen button, which is up here. Okay, now hit Windows, type G for GIMP. Okay, there it is. It's coming right up, people. Sorry about this. I want to show you a diagram so you know what it is that we're doing. Hit Control V for me. There we go. Hold Control. Okay, release. So new layer. I'm manning the mouse and she's manning the keyboard. That's why we have to coordinate like this. So here's what we want to do, right? We want our car to travel like this, nice and smooth. Okay, undo this for me, please. Okay, so in order to do this, we need to do Bezier curves between each of these points. So as I was talking to you about before, linear interpolation is what we basically have now. Undo this. So we need another point over here so we can linearly interpolate like this in a curve. Okay, mm-hmm. So undo this again. So we need to figure out where this point is going to be. And the way we're going to do it is as follows. Undo it one more time. Okay, suppose the car is here on the green, right? And it needs to go over here. Well, in order to know what the curve is, we're going to take the previous tile and get the direction from this tile to this tile. We're going to normalize this vector so we only care about its direction and not the magnitude, right? A normalized vector has a magnitude of 1. Mm-hmm. So it's perfect for us to multiply by a certain length, okay? Then what we're going to do is something pretty simple at first. We're going to take the distance between these two tiles, chop it in half, and use this as the length of this vector. So we're going to take this vector from the starting point of where we are at, drag it out for the duration of, for the length, for the magnitude of this half, right? So we're going to end up having we're going to have a point over here. And that point is going to construct a line that's about similar to this. So that's what we're going to start from, okay?
Okay.
Cool. So let's go right here and back to our code. All right. So go under the loop when the loop is finished.
Bye-bye, Mr. Loop.
Yeah, hit there and create a few variables on the fly. First, we're going to create a variable called vector3. So a vector3 variable. And we're going to call this one dir for direction, dir, semicolon. Now create another vector, which is going to be a float. And call this one dist for distance, semicolon. Okay. Now open a new loop for and go until the duration of the tiles. So same thing as before. Int I equals 0. Semicolon, I lower than tiles.length, semicolon, I plus plus.
Is that lower? Yes.
Tiles.length, semicolon, I plus plus. Close the bracket, open a squiggly, enter, close it.
Yeah, but I need to find a bracket.
Where is it hiding the bracket?
Where is the
Save.
bracket hiding?
Okay, so inside here, first we are going to try and get the direction. So in order to get the direction, remember what we need to do? We need to get the vector that goes from the previous tile to the next one. To the one we currently are on. What's the issue that you should already see?
Well, why do we need to take the tile before?
Because we need to get the direction to get where the control point is going to go, right? Problem is, what if you're at 0? What's the tile before 0?
The tile before 0 is the tile 61.
Yeah, but does the code know that?
Well, no, so we need to make it in a different way.
That's right. We need to make an exception for 0. So let's start with that. Let's go if I equals 0, 2 equals banana.
Whoops.
Equals 0,
Otherwise,
close,
it's not an if equals.
open, close, make an else already.
Oh, not there. Don't make an else and an if.
Okay, save. So let's go to the top one. The top one, actually, let's go to the bottom one, which is the one without exceptions, right? So this one is going to be, we're going to get the direction. So let's go dir equals. Now, do you remember how to get the vector that goes from one point to the to another?
Well, we do a lerp.
No.
Then
That's not a vector. That would move stuff. We're not interested in moving anything for now. We're trying to get the direction, the orientation, the aiming vector that goes from one point to the next.
well, no.
If you don't remember, it's fine.
No, I don't.
Okay, the way it works is you need to get the target point minus the starting point. Okay, so the target point right now for what we're looking for is the tile we're currently on, right? So it's going to be, open a round bracket, it's going to be tiles I, right? Because it's the tile we're currently looking at. Dot transform dot position. Try not to write every single letter, so. Okay, minus. Now this should be simple. Which one it comes before I?
Well, I minus 1.
Correctamundo. So you do tiles I minus 1 transform dot position.
Whoa, tools. Tiles. I.
No. Minus 1 needs to be inside the bracket. Otherwise,
Oopsies.
makes no sense.
I minus 1.
Yeah, you need a space before that minus 2.
Oh.
Yeah.
Oh, you're right.
Yeah. You don't, but you know, we want to be consistent.
Yeah.
Dot transform dot position.
I'll say row transform.
And close the bracket. Now what did we say? We need the vector to be?
Normalized.
Okay, therefore, dot normalized. Semicolon. Okay. Now,
Oh, that's not
will this always work?
Well, not if we get zero.
But we have an exception for 0. So all we need to do is fix that and then it will always work, right? Think about it. If you're looking at tile 61, what's I minus 1?
I minus 1? Well, it's tile 60.
That's right. So it's fine. If you're looking at tile 1, I minus 1 is tile 0.
Tile
so
0.
we're fine. Okay, copy the entire line that you've just written and put it inside the if.
Okay.
Right? Yep, paste it right there. And now obviously we need to change it a little bit. So the tile we're looking at is tile 0, but you could leave it at tiles I, right? And whereas we need to do minus which tile? We need to do the starting tile.
We need to do the starting tile.
Which is tile 61. And how do we get that number?
Well,
we've done this many times last time already, right? How do you get the very last tile of an array?
you do the dot length.
Yeah. And that gets you the count.
That gets.
So it's not really true because tile 62 doesn't exist. So you need to do dot length.
Minus 1.
Minus 1. So replace that I over there. That one, yeah. Replace that one with tiles dot length. That's it.
Oh, I wrote equals tiles dot
Length.
length.
Done. It's already there. Hit tab. Alright, save. All right, so now we have all of our directions. That is lovely. All right.
A bunch of dot lengths.
Not lengths. All right. So now, let's move on with our distance. So how far we need to go. So to get how far we need to go, we need to check the distance between our current tile and the next one. So instead of going backwards here, we're going forward, right? What's the problem with going forward? It's very similar to the problem that we got going backward. The question is, what's forward from 61?
0.
That's right. The code doesn't know that. So we're going to have to make an exception that's pretty much identical to the one that we made here. Okay?
Except it's pretty much reversed.
Reverse, that's right. So right after that if and the else, click there, hit enter, and make another if. So if, and here this time we're going to check for the last one. Therefore, if I equals tiles.length minus 1. Minus 1, close the bracket, open squiggly, enter, close squiggly, else. Save. Okay. And now what we're going to do here is we're going to go again with the second one because that's not the exception. No, we're not checking there. So go to the else. Here we need to calculate dist, right? So dist equals, and we're going to use an inbuilt function that the vector3 class has. So start typing vector3.
Oh.
If only you press tab every now and then. I don't know why
I was going down to press tab.
I know. But you know, you wrote the entire word. I think the letter V was enough. Dot distance. So that's it, that's enough. Just 2 letters are probably enough. Yeah, that's why you need to practice this tab thing. DI, and it should be already there. There. No? You open a round bracket, and what does it need? It should tell you now. It needs vector 3A and vector 3B. So it needs 2 vectors, just to figure out how far they are from one another, right? So we're going to take the position of the current tile, which is tiles I dot transform dot position. No closing bracket. You need the second one, comma. And here you're going to need tiles I plus 1, right? Because we're going to the next one.
Tiles I.
No.
I know.
You know full well that it's the index that needs to be summed plus 1. What does it? Listen, tiles is an object, right? Of type tile. What does it mean if you do tile plus 1? Tile plus an integer means nothing. The two are not compatible. What's an integer here? There's only one integer in front of your eyes.
The I.
That's right. So you want to sum an integer with an integer.
With an integer.
Yes.
I need to keep the integer in there, but not right equals. There we go.
I plus 1. Dot transfer dot position.
Yes. I'm getting very confused.
Looks that way. Dot transfer dot position. Now close the round bracket, semicolon. Actually, no, that's a lie. We need to divide it by 2, remember? So put a lovely divided by 2 at the end. Not
or
there,
multiply
outside.
by 0.5.
Sure, you want to multiply by 0.5? I'm fine with that.
We can multiply it by 0.5.
Much better. Okay, save. All right, now you can copy this entire line and let's put it in our exception if. So put it in there. And this one is going to be still tile I, but instead of tiles I plus 1, it's going to be tile 0, right? Because we have to go to the beginning. So yeah, replace that I plus 1 with a 0 and you're already done. Okay, save. So we got a direction and we got a distance. This means we know exactly where to put this thing. Okay? So all we need to do at this point is go down after these 2 ifs. It's still inside the 4 though.
Okay, so...
There. No, yeah. Enter. And here you want to use that array that you've made, control points. So control points I equals, there it is, tab. points I equals, and here we need to use a small formula ourselves, which is going to be tiles I dot transfer and dot position, and here we're going to sum it the vectors that we got, right? Plus there, that's the vector, times the magnitude, dist, times dist. So this means we are gonna go forward from the current tile's position by the direction that we got from the previous tile to this one for as long as half of the distance between our current tile and the next one. Do you understand? Okay, save. So before we continue doing anything, let's give a brief demonstration of how this looks like. Let's create a temporary public game object right under look target. Go to your variable look target. There, hit enter and go public game object. And call this one CP or something. Semicolon. Okay. Now go after where you've populated your control point. There. No, further down. Down. There. Up. You've just done it. The last line of code you wrote.
Here it is.
Yeah, hit enter at the end and go instantiate. Open a bracket, CP, comma, control points I, that's where we're gonna put it, comma, quaternion.identity. We're just not gonna rotate it at all.
Yes, quaternion.identity.
Close the bracket, good work with your tab, save. Okay, now let's go back to Unity, because we're ready to test this. And go to your game manager before you do anything. And I think we have a
I hope we don't get the same problem as yesterday, remember?
Well, we'll see. It'll be funny if we do. Go to your prefabs and drag CP into CP. We had already created just a basic cube to use to test, right? So let's hit play now to test it. And let's see what we'll find. Boom, there are all of our cubes.
Except this one's in the wrong place.
Well, we'll worry about that in a minute, right? But yeah, that's a very good point. So as you guys can see, just wait before you move. As you guys can see, these points are using that little formula that we made in order to try and build almost a trajectory of a curve that the Bezier quadratic formula is going to use in order to trace this line more or less. It's not going to be super perfect, but for the intents of this particular game, I think it's going to be just fine. Right? So for example, the distance being 0.5 is not exactly ideal, but it should work okay, right? There's many much more complicated ways of doing this much better. We are not going to look into that for now, right? I don't want to go into mathematics that is too complicated for Zoe to understand. Okay?
Okay.
So we're going to stay where we are for now. Okay, so there they are. This is just to show people how they look like, right? And actually, since we're here, let's quickly make a small change to the code. Right here, type dot transform dot name equals I dot toString. Open close. Save, sorry, my bad. Okay, so let's redo this one more time just so we can show the result. You'll see guys over here, now we've named them, and you'll see that 0 is right in front of tile 0. 1 is in front of tile 1, and so on, and they're all ordered. Okay? Now Zoe's pointed something out. Let's look at tile 5, and let's look at its control point. It looks a little bit weird, because the car is going to make a big turn here, as opposed to...
But it's not going to go... Whoa.
Yeah, well, it's going to do a bounce because of this particular thing. We'll see how this looks like in game, all right? So for now, all we're going to do is we're actually going to leave these control points blocks for now. They don't hurt anyone, right? Just so we can see them later, because we are going to make some modifications to make that look a little bit better. But for now, before we do anything, let's now code how the car will follow these curves.
Okay.
Okay? So first, we need to actually...
Follow the pile of lerps.
That's right. First, we need to prepare our little curve code, right? So let's go, we're still in Game Manager, aren't we? Okay, so let's go to the very bottom and create a new public function this time around. So after tile, right there, hit enter twice. Go public vector 3. So this one needs to return a vector, right? 3. And you're gonna call this one quadratic Bezier.
Quadratic.
Capital B, Bezier. It's French. Bloody French people. Oh, sorry, I'm not supposed to say this online, am I? Open a round bracket. Vector 3. By the way, let's explain this, right? So what are we going to need? We said we need 3 points. The starting point, the control point, and the end point, right?
Yes.
And what else do we need? We need the controller itself, which is a float. That thing that goes between 0 and 1. So let's start with the starting point. So we're going to call this one SP. How lovely that you're blowing your nose on live. Sorry guys, she's a bit sick. Bear with it. Plus she's a child, she gets away with it. Vector 3 space SP. Call it SP. Starting point. Comma. Now we're gonna do another vector 3.
Okay.
And this one we're gonna call CP for control point. And another vector 3. Can you guess what it's gonna be called?
EP.
Well done.
And then are we gonna have yet another vector 3? Because we need the controller.
No potato. We need a float. So EP,
yeah, how silly.
focus, EP, comma, float. What do you want to call the controller?
C.
C. All right. Close the bracket, open a squiggly, enter, close the squiggly. Hey, you forgot to close the bracket, which is slightly important.
Slightly important.
Right here. Close the round bracket.
Ooh.
Now let me see how we do it usually. Yeah, there's a space. Okay, save. Now it's giving you the red squiggle under quadratic Bezier because you're not returning anything. You didn't save yet. Save. Thank you. All right, so what are we gonna do? We're gonna create 2 vector 3s on the fly in here. Okay, yeah, start typing, it'll fix itself. Vector 3. Okay, call this one P0. Go equals.
With a real with a real 0?
Sure, that's fine. Equals. And now you're gonna do vector3.lerp.
Oh, but here we go. Vector3.lerp.
Okay, so let's remember the formula, right? The first lerp is between the starting point and the control point. So SP. What's the next one?
CP.
And then
C.
that's right. Close the bracket. Semicolon. Can you guess how to do P1 now?
Well, first I need to write it.
Let's see.
So first I need P. So vector 3, P1, and I'm gonna guess. Yeah, just.
Yes.
Well, I don't really need to guess, but anyway. Dot lerp. And it needs to go first, start from the control point to the end point with the same controller.
Yeah, close the bracket, semicolon. Perfectamundo. And now we need to do the final one, the return, right? So hit enter, return. And guess what? It's another vector 3 lerp.
Yep. Return vector 3 lerp.
Open a round bracket.
Between the 2 lerps.
That's right. So
P0, P1,
and
for the controller, I guess still C.
that's correct.
C hasn't changed.
Well, I know, but as it increases in all 2 of the P0 and P1, it also increases in the return at the same time, and that's how you create that curve. Okay, so let's save this. Now we've got this lovely curve ready. Now all we need is
call
our
the function.
yeah, we need our player motor to actually call this. So let's go to our player motor.
Okay, there's your stuff you did yesterday.
What are you
There's
talking
the things you did yesterday.
Yeah, sure, I have my notes here.
Yeah, your notes.
You're selling me down the drain. I'm being thrown under the bus.
Who's being thrown?
It's in execute move. That's where you want to go. Into the... yeah, right there. Okay, so here, let's see where we move the car. It's in transform.position equals vector3.lerp, blah, 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 blah. That thing, right? That's where we are doing our linear interpolation, our lerp. Now, we don't want it to be linear anymore. So
just interpolation.
hey. So here's what we're gonna do there. comment out that line that says transform.position, etc., etc.
Transform.position, etc., etc.
Okay, now add a line after it. Save. And here's what we're going to do. Transform.position.
Oh, comma, position.
Yeah, equals. And now it's going to be game manager.script. Dot quadratic Bezier.
Bezier, which is spelled.
It's already there. Hit tab. Open a round bracket. Hit enter. Let's go down one line. Okay, so we need to give it the starting point. Now, obviously, the starting point is the tile we're on, which we do know. It's the current tile. So go current tile dot transform dot position.
Current tile?
That's what it's called in this script. See it up there?
Oh,
Current
right.
tile dot transform dot position. Comma and enter. Now, here we need the control point. Now, the control point, we need to go to the control point. So it's going to be game manager dot script. That's a bit clunky. I think we're going to change it soon. Dot control points.
That's a bit cramped.
Open a square bracket. Current tile.
That's a bit clunky.
You'll see. You'll see how long this code is for no reason. Current tile dot, I think it's called tile ID, because I think we're keeping the ID. There it is, tile ID. Close the square bracket. Dot transform dot position. Oh no, it's already a vector 3. My bad. Remove this. Comma. And now we need the endpoint, which is next tile. So next tile dot transform dot position. Now comma, we need the controller. Enter. So our controller is going to be the passing time. Okay, hit enter. Nope, no commas. That was the last argument. Okay, now on the next line, close the bracket, semicolon. Now indent this bracket. So shift tab, save. Okay. So let's see what this does, right? So it does that quadratic Bezier. It takes the current position as a starting point, the control point of the current position as a control point, and the next tile as the end point, and it feeds you the passing time, which is a number that goes between 0 and 1. So this should work perfectly. So let's go in Unity and test this out.
Okay.
Hit play. Okay, now slowly hit the forward button gently so you can show people, right? So ignore the fact that the car's turning weird, that's fine. But you should see that it's actually going in more or less a curve. Now you'll also see that sometimes it does some weird bounces. For example, right now you'll see it. Go forward by 1. No, go forward by 1. So
I'm going backward by 1.
yeah, forward, forward, forward. Okay, this next one is gonna be fine.
Here, people.
Yeah, no,
So
wait, you need to click on the game scene. Okay, now
Oh,
press forward once. This one's fine, right? Press forward again. This one's bad. This one's bad, right? So what we're going to do is we're going to try and find some kind of cheap solution to figure out how to force that control point to be straight. Okay, so you can stop the code now. And stop the code, please. And what I think we are going to do is we are going to use angles between vectors to figure out if they are steep enough to, in fact, rather not steep enough to, in fact, be considered straight.
Okay.
Okay? So that the angles are not extreme enough so we can consider them straight.
Okay.
All right, so for this, we are going to need a few more variables. Let's go back to our game manager.
Back to the game.
Yes, ma'am. Game manager. Come on.
Come on now.
All right, go up. Yeah, so after that public game object CP, hit enter. And what we're going to need here is going to be I don't think we need it public, do we? I don't think so. So make it serialized field private float. Full coat.
Full coat.
Just hit tab and we'll fix it. Okay, float, and call this one control point minimum angle. and give it a default value of 15 float. So a 15-degree angle should be all right. Save. Okay. Now that we've got this, let's go to our start function.
I didn't see you type this code yesterday.
Yeah, I know, because I did it after you left. Because I was trying to figure out how to fix this in a cheap enough way. So go after that float dist.
After the float dist.
Hit enter and create another float and call this one angle test. Semicolon. Okay. All right. So here's what we need to do. We cannot just check the angle that we need to check is between our current tile and the next one, and the next tile and the following one. Okay? So we need to check 2 tiles ahead. Now, what's this problem? If we had a problem with checking the last time before, and we had to do tiles.length -1, right? Remember that?
Mm-hmm.
We're going to have the same problem with yet another tile. Because if we are at tile 59, then there's 60 and 61 were fine. But when we're at tile at 60, we got 61, which is fine, but 0, which is not fine. And then when we're at 61, we got 0 and 1. So we need to be a little bit more careful even, okay? So after you've calculated dir, the direction,
Dir.
yeah, look where dir is being calculated, further down.
That's
Those, okay, after that if, there, hit enter. And now we're gonna create an if for not only the last tile, but the one before the last. So which one is the one before the last? I equals equals?
I is,
So-
it's the last -1.
That's right, so
So I is
tiles.length
tiles the length -1 -2. Again.
-2. That's right. So I equals no. Hold on.
first
I
one.
equals stop deleting wrong stuff. I equals tiles.length -2. -2. Close the bracket. It's not definitely not a float. Open a squiggly.
Yes.
Enter. Close the squiggly. Else.
It's a pile of ifs here.
Yeah, wait, there's gonna be more. Now copy this entire if, just as it is. All of it, including the else.
Oh, Jet. You're right.
Copy it and paste it inside the else.
Oh.
And now replace this -2 with -1. Right there. So we're gonna test. Are you -2? Then do something. Are you not? Are you -1? Then do something. Are you not? Then do the normal one. That's how we're gonna do it. Okay, so let's go to the else of the -1. And here, what we're gonna write is angle test equals. If you only use the tab key every now and then, trust me. Why do you not trust me? Why? I don't know. Okay, angle test equals. She has the gall to laugh. Unbelievable. Vector3.angle. Again, are you gonna type every single letter? That's it, it's already there. You needed one letter. Okay, dot angle. Open the round bracket. Okay, and here we need to feed it what? What does it say there? Vector3 from, Vector3 to. So we need two vectors, and that between them we're gonna find the angle. And the angle is gonna be a float. That's what it tells us, right? Which is very nice. So, what are we testing? Well, we're testing tiles I plus 2, right? So 2 tiles ahead of us.
Okay. Alright, and this time I'll remember to keep it in the brackets. But I won't remember to put not put the equals. Plus 2.
Plus 2. And remember, we need directional ones, okay? So we're going to have to say I plus 2 dot transform dot position. Minus, to get the direction, tiles I plus 1 dot transform dot position. Comma, tiles I plus 1 dot transform dot position.
But we already put it.
Trust me, I'll explain it soon. I plus 1 dot transform dot position. You clearly don't remember how to find directions between two vectors. Dot transform dot position. Minus tiles I dot transform dot position. I'll explain it just in a second. Just finish writing this and I'll explain.
Tiles I dot transform dot position.
Close the bracket, semicolon. Not the square bracket, the round bracket. Semicolon. Okay, save. And here I'll doodle it for you so you understand. So here we are. Okay, so here what we do. Here's a lovely curve. This is a good example of our problem. Let's say we are here.
We're there.
Okay, so we're gonna go forward by 2 tiles, and we're gonna take this tile and this tile. And remember, we're gonna take this tile minus this tile, which gives us this vector. Okay, and then what do? We take this tile and this tile and take this vector. Now check these 2 vectors. Do they form an angle?
Well, if they do this,
It usually makes an acute one, by the way. So it's gonna go like this, and this is the angle.
Oh.
Now is this angle more than 15 degrees? I would think so.
I don't know.
Yes. So this is about 90 over here, right? So this one is clearly quite large. It's 60 almost. So it's a pretty big angle here. Okay. Now hit undo a couple of times for me. More, carry on. More. Stop. Okay, now let's say we're here. Now remember here we had a little bump that annoyed us, right? So we go 2 tiles forward, 1 tile back, get this one. Now this 1 tile back, go to the starting one, now get this one. Now, what angle do you think these 2 form? Something like this.
Something like
Is this more or less than 15?
I don't know.
Well, this is very, very small, right? So if this is 90, this is 45. There, the 15 should be about here. This is likely smaller than 15 or something. You know, we could always change that to 20. Point being, now we know that our bumpy thingy, which would be here, right? We would go like, hey, actually, we don't like it here. We're going to force it to go back to the center. So we're going to force a straight line. Do you understand? That's how we do it. Okay. And this is going to help us verify whether that angle is or isn't higher than 15. So now let's do the other exceptions. So copy the entire angle test line and put it inside the -1 over there. Paste it in there. Save. Okay. So let's see this one. This one cannot start at I +2, I think. Right. It needs to, instead, this is like the super exception. It would mean that we're on the last tile. Therefore, the second tile ahead is going to be tile number 1. So replace that 1 plus I +2 there at the beginning. Replace that one.
Okay, so here.
Yeah, that one. Replace it with 1. Literally just the number 1.
Bye-bye.
All of it. The second one, therefore, gets replaced with 0.
Bye-bye.
And then the next one is also 0, because it's the same one.
Bye-bye.
Oh, you forgot an I. I0.
I0.
Okay. Now copy the previous line again. You already have it in memory. Paste it inside the -2. Up. There.
Here.
Paste it there. Save. Okay. Now this one is, say, tile 59. So we got, 60. So we got a 61, which is valid, but 0 after that. So the first one there, that one's replaced with 0, and you're done. Okay, save. So our angle test is now ready. Now all we need to do is
Wait, sorry, no.
No, what's up?
This else was is already full.
Yeah, the else is fully complete. All right, now hit enter exactly where you're at, because now we need to check the angle thingy. Right, so we're gonna say if, open a round bracket, angle test lower the control point minimum angle. There it is. Close the bracket, open a squiggly, enter, close the squiggly, else, etc.
The usual stuff.
Actually, I'm lying. We don't need the else. My bad.
Not the usual stuff.
Oh, careful, you're removing too
But
much.
I'm removing other ifs.
Okay.
Don't remove other ifs.
Don't. Okay, so inside here though, guess what we need to test? We need to do another test for the last tile. Sorry. So you go if I equals tiles dot length minus 1, because we need to rebuild the dir now. We need to override the dir with the new dir, because we know that the angle is not large enough. So close the bracket, open a squiggly, else.
This time you're not lying.
This time you're not lying.
But I'm
Copy
lying
the dir from up there. Copy the second dir. That one.
this dir.
Yeah, copy that. Paste it in the else on the one you've just created. Okay. And so
Start has a pile of code in it now.
yeah, I know. And we're gonna have to move that at some point. So that one, instead of a tiles I minus 1, you replace that minus with a plus. So we're instead gonna go to the next one.
Okay.
Yeah. And we also need to do a switcheroo. So you need to take tiles I transfer dot position and put that one after the minus. So you need to invert who is in front of the minus. So cut all of that. Cut that one. Put it in front. So before tiles I. Paste it. Space, minus, space,
Space plus space.
minus.
Oh, but you just said put
Space.
a plus.
No, I said a plus in the I plus 1.
Oh, then I better
And
put
remove
it
that
in the
minus.
I plus 1.
Save.
Wait, where's the I plus 1?
It's done. You've done it already. Save.
Oh.
And now copy this entire line and paste it in the if. See, as you guys can see, math is already starting to get a little bit overwhelming. My 8-year-old here, I'm fairly sure, is not following most of this, but that's okay. You guys should be. Okay, now you want to replace tiles I plus 1 in this if with a 0. Not that one, that one. That's right.
This guy.
Okay, give it a save. So we've changed our direction. Now this should already work, so let's go and test it. Let's go to Unity, hit
Wait,
play.
Because the gigantic starts the...
Well, go to Unity, hit play.
Not GIMP, Unity. Unity.
That's how French people say it. Hey, look! That one's now straight.
Yay!
So try driving the car, and it goes straight. Isn't that lovely?
Woohoo!
Okay, it's working fine.
We got a good Bezier curve now. Except now the look at point is...
Yeah, well, now we're gonna fix the lookout point. How's that? Okay, you can stop the code. Give it a save. Alright, so now let's also fix our lovely friend. In order to fix our lovely... Well, we should do a few things. In order to fix our lovely friend, here's what we're going to do. We're going to place our lookout point, our look target, right, just in front of the car. Okay? And we're going to make it so that it goes on the same curve as the car, just slightly faster. Okay? When it goes forward. When it goes backwards, we're going to have other problems. But for now, let's worry about this. Okay? So, let me think. What was I saying here? Right. So let's begin with adding this stuff. So for this, in order to make it go faster using the same controller, do you know what we're going to use?
What?
An animation curve.
Oh, yes.
Right. So let's go to the code. Let's go to the game manager.
Code, game manager.
Go to before start, obviously. Scroll up. There, after that 15-degree control point minimum angle, hit enter. And go on another, no, actually, we need a public. So you need a public animation curve. Now this one is not worth tabbing. The one that is not worth tabbing, you will. Oh boy. Okay, you need to remove everything.
Okay.
So start typing animation C, and then you can tab. Okay. Now space, call this one curve underscore. That's how we usually call these. Forward look target. Semicolon. Okay, now let's go to the player motor. copy the entire transform dot position dot equals game manager, all of that, not that one, the one after.
Oh.
That one.
But look.
What?
There's not. Oh, yeah.
But look!
I thought it was.
You wrote it a minute ago. It's a bit longer than that. Okay, copy that entire thing. Paste it underneath itself.
It's from code.
No. Underneath itself.
Oh, yeah.
The player motor still needs to control this. Paste it. Okay, now instead of transform dot position here, you want to go to game manager dot look point, whatever it's called, dot position. So game manager dot script dot look, I think it's called, there it is, target dot position. Okay, so now it's doing everything correctly, except we need to add that curve to the evaluation of the passing time. So double click on passing time and start typing game manager dot script dot curve, there it is, dot evaluate, open bracket, passing time, close bracket. Okay, now let's go back to Unity and assign this curve, because curves don't get assigned by default. Oh, we got an error.
It's got a.
Oh, you put a semicolon back there, banana.
I'll put a banana.
Save. Because the semicolon is further down, you see it there. Okay, so yeah, go back to Unity.
We got 2 errors.
It should all be gone. Hit play.
It has begun.
Okay. Now,
But it's the curve.
that's all right. Move forward. Ah, you're right. My bad. Stupid daddy. Go to game manager. Game manager. Okay. Now choose the curve. Now which curve will you pick? Move this panel on the left so people can see.
Hello.
Okay. So which of the curves downstairs will you pick?
Downstairs.
Yeah, there's a few. Just don't look at the ones that are further right. Look at the first 5. Which of those will you pick? So the first one's linear and straight. We don't care. The second one is linear, which means it makes absolutely no difference from what we have. The next one, what does it do?
Well, what does it do?
What does it do? I'm asking you.
But I'm asking you. I don't know what it does.
Well, of course you should know. If on the x-axis you have time and on the y-axis you have value, right?
But what does value mean?
Well, how much that passing time information is going through, right? So is it going slowly in the beginning and fast at the end, or vice versa?
Well, it looks quite far down at the bottom.
So
it looks like it's going slowly.
That's right. Whereas what do we need? We need our control point to precede, not control point, I'm sorry, our look target to be faster than the car. That's right. We want something that starts fast and then slows down. Mm-hmm. Okay, so you can close this.
Hey, upside down, I think this and this are
That's
inverted.
right, they're inversed. Yeah.
And if you probably click fast enough, they like bouncing.
Sure. Okay, close this. Hit play. Now test it. Again, move slowly so we can see.
Sure, but how do I move slowly?
Press forward. Look at the car. Look at it.
Woohoo! I just saw it bump though.
Yep, and I know why. Oh, if you're going backwards, it's another story. Don't go backwards, banana. Just go forward. We still need to fix backwards.
It's bumping like crazy.
Yes. And the reason why it's bumping is because there is a short period of time for which the look point and the car are basically on top of one another. So the car doesn't know what to do. Okay? So what we're going to do is we're going to put a small limit as to when the car can look in that direction. And that's very easy. So let's go to your player motor, open your update function. Actually, before we do this, let's go and create a variable for this inside the game manager. So go to the game manager and add one there. Yeah. And it's going to be a public float. Let's call this one look minimum distance. And give it a default value of 0.05. So very, very close. Okay. Now go to the player motor again. So before, in update, before you start looking at things, put an if, open a bracket, vector3.distance open a bracket, transform.position, so the distance between the car and what? And the look point, which is in game manager. So comma, game manager dot script dot look target dot position. Dot position. Now close the bracket. So now we have the distance.
If vector 3 the distance.
Yeah.
What about the argument?
Well, close the bracket. We're done with the arguments of this function, but now we need to tell it what about the condition, right? And the condition is
yeah, that's what I meant.
If this distance, no, close the bracket.
Oh.
If this distance is higher than.
But then why do we close? Oh, we're closing that bracket.
That's right.
Sorry.
That's okay. We're closing this
This
bracket.
is higher than.
Game manager dot script dot look minimum distance. I think we called it. Close the bracket, open a squiggly, and put transform look at game manager inside this. So we're only gonna look at the thing if the thing is far enough from our car. Safe. So if it's too close, we're not gonna do it. So that bouncy feel should kind of go. Let's see if it does. Go back to Unity, play.
It was here at the start, so I'm here.
Okay. Oh, it still kind of does
Still
it.
bouncing.
Yeah. Well, what I think we're gonna have to do for that, because our mathematics isn't that sophisticated. Stop going backwards. Well, we're gonna have to apply a fix there. We're gonna simplify the way things turn here a little bit. Okay. We're gonna basically change the art of how we place the tiles a little bit to make these bounces less present. Okay. Because it doesn't make a huge difference in the end of the day.
It just bounced the ton over there.
Yeah. But as you can see, most times it works fairly decently. Now, okay, so the last thing we're going to do today is we're going to fix this bloody backwards movement, right? So the problem with moving back is that it uses the wrong control point. It uses the control point that's forward. That's why you have this weird movement. Okay, stop the code.
It does look kind of funny though. Look at them.
Sure. Okay, so here's what we're going to do. We are, by the way, when we go backwards with our cars on the path, we want to still face forward. Okay, so it's gonna like reverse the car. Okay.
Okay.
So we're gonna need another curve, and this time, how does the look transform need to move? Slower than the car. So we're gonna need the opposite curve of the one we currently have. Right. So, but anyway, let's begin with the important bits. First of all, I want to change the tile a little bit because it's a little bit annoying. So go back to Visual Studio. Visual Studio.
Oh, Visual Studio.
Visual Studio. Visual Studio.
I do.
Now go to the tile. Okay, and what we're gonna do is gonna make the tile remember the previous control point and the next control point from itself. Okay. So after tile ID, add two public vector 3 variables. So start with one public vector 3 forward control point.
Oh yes, I remember this. You showed me this one.
And now do another public vector 3 backward control point. Backward control point, semicolon. Save. Okay, and now you want to add you want to request two more vector 3s in setup. So after int ID, add a comma and go vector 3 F, comma vector 3b. So you want a forward and a backwards. Comma vector 3b. B. Okay, and after assign in tile ID, you want to also assign forward control point to F and backward control point to B. So go ahead, forward control point.
What's this there?
Don't worry, it's normal because now this function wants more stuff and game manager isn't giving it, so it cries. Okay, so forward control point equals F.
Wait. Forward control point equals F.
Backward control point equals B. It's already there.
Control point equals B.
Okay, you're doing a good job with the tab. So now let's go to that error. Double click the error. All right, so that's the problem. Okay, obviously we can't set up there anymore, right? Because we don't know the control points. So that's a big issue. So delete that tiles i.setup.
Done.
Yeah, give me a moment here. Okay, yeah. So now go all the way to the end inside start of all of these, of this big 4, right here. Okay, hit enter. Add another 4 for exactly the same distance. So we start again, yet again. Int I equals 0, I lower than ties.length, I plus plus. Okay, now again, of course, we need to check if I is 0, because if I is 0, its previous point is going to be, I know you love it, if I equals 0. It's not that bad.
Yeah.
We need the else too.
As usual.
Okay, now in the second one, let's go with the non-exception first. It's going to be tiles I dot setup. Open a bracket. I is the ID, comma. Now we need the vector 3 forward, so it's going to be control points I. Comma, and now we need the one before this, so control points I minus 1. Ah, chaos. Destruction. No!
Oh, Johnson forgot to end the bracket.
No, it's a huge no, like a 64 size no. Yes, close the bracket, semicolon.
Only size 64.
It's huge. Okay, save. Now copy this entire line, put it inside the if. Okay, and now what you need to change is the second part where it says control points I minus 1. We need to go to the last one, which is control points of control points dot length minus 1. So double click that control points, copy it, double click on the I inside the second control points, paste dot length. All right, so that gives us the control points saved and stored inside our tile. Now the last thing we need to do is we need to go to our lovely motor, but our motor is also going to need a few pieces of information. So go to the player motor. Oh, my bad. I forgot that I made this change. Oops, sorry. For all the people watching at home, you guys need to know that I've basically added a request for the direction on the tile, on the move toward here, which we didn't have before, and I forgot to remove it. I apologize. So here when we go get tile, we go the direction and we get the tile, right? Which is on the request for movement right here, move toward, right? And so here's the -1. And then I add -1 as well, because this is for the get tile. And then I send -1 to the other side as well. Actually, this is probably not very efficient, but we'll live with this for now. So yeah, so let's rewrite it as it was before. So the way it was before, it didn't have this -1. We just add -1 over here and add 1 over here. And then in player motor, we request int direction from move toward, right? And then we send direction to our enum, to our enumerator, which also has to request a direction. Okay? So now we're going to use the direction. Where? Right here. So you go if direction higher than 0. Yeah, let's start with forward. If direction higher than 0, close, open, close, else, close, open, close, blah. Thanks. Save. Okay. Now cut the entire transform dot position, all of that, all the way down until yield.
Whee!
Yeah, without the yield. There. Cut that. Put it inside the top. Inside the, yeah, there. Now we need to modify this one. Oh, as you can see, it's made a mistake. This happens every now and then. Hit tab. Save. Okay, here we are. So here we're gonna make a few changes. So here it says current tile transfer to position. Now instead of having this annoying here, we can go to current tile dot forward forward control point, right? Because we've invented this variable and it's nice and lovely. Save. Okay, and now for the next one, same thing.
Control point.
That's right. So current tile dot forward control point.
Backward.
No, still
right?
forward. Still forward. This is for moving the look target.
Oh yes, then still forward.
And now you want to take this entire thing, and you go copy, paste it right here.
So
Okay,
let's
and this one is
paste.
backwards. So start typing B. It should already appear. There it is. Tab, and this one as well. Now, we said that to go back, we still need our viewpoint to actually move slower than the rest. And right now it's using the forward target curve. So let's go and copy our curve. This
Make
one
a
here.
different curve.
Copy it. Ooh, yeah, and rename the second one to backward. Yeah, let's go in order. No, just the word forward. Replace it with backward. Save. Copy this. Go to player motor and paste it here. Save. Okay. Now we need to go and assign it in Unity.
And we want the one that goes slow first, the inverted
Which
one.
is which one?
Which is
You choose it.
that
You choose it.
that guy.
That guy. Click. She was pointing at the screen, which doesn't really work for when you're recording video.
Sorry.
Okay, that's okay. Close that. All right, so now we should have movement backward. It kind of works. So let's test it. Hit play.
And I'll move backward.
Move. Yeah, seems to be going okay. Now
Bye-bye.
move forward. Our car isn't helping us very much because we can't really tell what the front is and what the rear is. So it's kind of difficult. Maybe we're going to make a change later to see if this actually works properly. But it should.
Here it went bomb da dum dum.
Yeah, we're gonna. That's because the angle isn't recognized. So watch this. Let's try and fix it. Okay. So select this tile. Now hit F while you're here. See, we selected the model. That's not what we want. We're gonna select the object, and we're gonna drag it down just a little bit, just like this, so it's straight. Okay.
Okay.
And now let's hit play. Try it. Go forward. Oh, that was harsh. Oh, I think we broke it even worse now. What am I doing? Okay, so let's try this just a little bit gentler. Go and try. Nope, still bounces. Okay, so I think I know what the problem is. We're gonna go to this tile over here instead. And hold shift for me. Yeah, and that's release shift. Let's try this. It's a good thing nobody heard that. I'm not gonna squeal on you. I'm not gonna say what you did. Hit my forward. Okay, it's not too bad. Yeah, I mean, definitely we could do an improvement
Look
of the
at here.
mathematics.
Look at this. It looks really bumpy on this side.
Yeah, no, this, you're right.
Yeah.
Oh, rubbish.
Rubbish off.
Yeah, I'm trying to adjust that. The problem is that our mathematics is just too simple.
Did you
It's
see that?
fine. Yeah, we'll live with that. We'll live with that. It's brilliant. I told you, if we make things a little bit more straight like this, I think it's going to work a lot better. Okay.
Did you do that? I didn't even notice it.
Do what?
Make it straight.
No, you had it already like this. Okay, so give it a save.
Go to save.
Okay. Now, one thing we're going to do right now is we're going to remove that addition of those block instantiations. We don't want those. Okay. So let's go to the game manager. CP, off you go.
Bye
See you later.
And let's hope it compiles this time.
Well, look, we're gonna have these two problems. Yeah. Actually, I'm talking rubbish. This one, save. So let's see, because Unity sometimes gives us a little bit of trouble when we remove those. So let's see, and it's gone. So we're fine. Let's apply our board, and let's apply our car, and let's save. And here's what we're gonna do. We're gonna try and build this to see how it looks like in game.
Ooh, we're gonna build it.
Build it. Hey, tabletop cars, that works.
Tabletop car.
Building.
Building.
We need to wait. There's nothing we can do. There's nothing we can do. Okay, it's built. So, open tabletop cars. And we're gonna go to this display. Play. Oh dear, sometimes Unity does this and I don't know why. Anyway, hit play. Move forward.
Hiya.
Even that bounce isn't that bad. It's kind of cartoony almost. We can always increase the angle or change the angle. It'll be fine. Look at yeah, there's a few bounces there. I think we need to do something with the angle. It'll be okay.
Look.
Yeah, well, if you stop doing that, it would work. Right, remember that this is just temporary. We're gonna make the car move by many tiles. Probably this is what we're gonna do next time. Okay?
Okay.
So, is it perfect? Far from it, but I think it's alright for now.
Go!
Sure. Okay. Hold Alt and hit F4. It's the only way to quit for now. Alt, not Control. Potato. Okay. So, thanks everyone for watching. This will be it for today, and we'll see what we're gonna do next time. We're probably gonna decide as we do it.
See ya.
Thanks for watching. Bye.